Hello, friends. Look at what we are asked to evaluate. And remember, we are still discussing differentiation. And in today's class, we are also continuing with chain rule. So, can you evaluate this? If you can do it, let's do it together. If you can't, let's still do it together. And I welcome you to our today's class. Now, let's do this together. Remember, you have a lot to learn. So, ensure to stay through the end. Okay, to read this, what it means is d dx of root 1 minus x squared. So this is what we are asked to evaluate. This simply means it is the same thing as saying that if y is equal to the square root of 1 minus x squared, okay, find dy dx. So if you see this, it also means this. I hope that is clear. Now, how do we differentiate this? Remember, we said in our last tutorial that whenever you see an expression in radical form or exponential form, whereby you have two functions in one, we make use of a technique we call chain rule, or function of a function, or composite rule method. Now, let's see how to differentiate this. Okay, remember, it's very simple. So we're going to begin with, this is our y to be equal to this. Okay, now we can say, let's take, remember, for you to use your chain rule, you have to differentiate twice because it has two functions in one. Okay, so the one inside the root is the first function. I hope you are getting it. So we can say, let that one inside the root, let the whole of this, which is 1 minus x squared, let it be u. We can say, let u be equal to 1 minus x squared. Remember, you can use any variable other than u. Okay, so if our u is this, then what does it mean? It means that our y, which is the whole function, is equal to this. Our root will now be root of, instead of writing this, I'm going to replace it with u. So I'm going to have something like this. Okay, now remember that in indices, that when you have root x, it is the same as x to the power of half. I hope that is noted. So what this means is that if y is equal to this, it is the same thing as u to the power of half. So this becomes our y value and this is our u value. Now, what do you do next? I'm going to show you. What you do next is, we are going to differentiate these two functions, the first and the second. Then we gather them together. So let's do it together. So for differentiating the first function, if you look at it, you notice this is a function of u and x. These are the two key variables we have there, u and x. Okay, so if you want to differentiate this function, what do you call it? You are going to name it du dx. Okay, will now be equal to, then we differentiate one. Remember, in our previous classes we said each time you have a constant, differentiating it will give you 0. We have tutorial on that. I will leave the link. Okay, so for differentiating one as a constant, we are going to have 0. Then we have minus sign. Okay, then we want to differentiate x squared. Remember, this is what we have. If you remember your power rule, which says that if y is equal to x to the power of n, then dy dx will now be equal to, use the power to multiply. So we have nx, then take 1 from the power. Okay, this is what we have in our power rule. And if that is the case, if this is what we have in power rule, which is also your formula method, it means that if I want to differentiate x squared, I'm going to have these two will multiply to give me 2x, then I'll take 1 from 2 to give me 1. And anything to the power of 1, any letter or variable to the power of 1 is what is that variable. So this will give us 2x, meaning that if I differentiate x squared, I am going to have what? 2x. I hope that is cleared. Let's take it again. Having identified your u and y, differentiate u. If you differentiate u with respect to x, it will give us differentiate 1 is 0 because it's a constant. Then to differentiate x squared, use 2 to multiply. We have 2x. Take 1 from 2 is 1. And any variable to the power of 1 is that variable. Okay, so this is what we have. Then 0 minus 2x will give us negative 2x. So this becomes the value of du dx. Now what do you do next? What we need to do next is to also differentiate the second function. Okay, so this is what you want to differentiate. And if you look at it critically, you will notice that what you have there now is y is equal to, what we have is y is equal to u to the power of half. Okay, so this is what you want to differentiate. Now, what do you do? If it is a function of y and u, what will you call it? You're going to name it dy du. Did you get? This is y and u, so you name it dy du. And if you are differentiating it, what do you have? This will give us, remember you have u to the power of half. Using the same power rule, this half will multiply to give us half u, then take 1 from half. And half minus 1 will give us negative half. I hope that is clear. So it means that if I differentiate u to the power of half, I'm going to have half u to the power of negative 1, negative half. So this is now what we have for our dy du. And this is our du dx. Now, what do we do with these two differential values? And I'm going to show you. So in short, to stay true. So what we are going to do now is we are going to remember the technique which says for the chain rule that if you have your y as a function of from what we are given, then the chain rule says that dy dx, okay, is equal to, remember what we are given is y is equal to root of 1 minus x squared. I hope you know that. So it's a function of y and x. So according to your chain rule, it will now be dy dx is equal to, our chain rule technique says, will be equal to dy du multiplied by du dx. So this is your chain rule. I hope that is noted. Okay, now having stated this chain rule, now we are going to use it to now simplify. So it means that our dy dx will now be equal to dy du. From what we have differentiated, gave us this value. Okay, so we're going to have half u to the power of negative half, then multiply it by du dx. What is your du dx? It is negative 2x. I hope you see how simple that is. So we are now going to gather this together. Okay, so in gathering it together, I can use this half to multiply negative 2x. Watch, half multiply negative 2x, make it to be over 1. This will cancel. So we are left with 1 multiplies negative x will give us negative x. Okay, let's take it to the other side so that we can conclude. So we are now going to have finally, this will finally give us, we are going to now have, for multiplying this, we have negative x. So we have dy dx is equal to negative x, okay, u to the power of, for multiplying this, it gave us negative x. So this is what you have. Then return u raised to the power of half, negative half. But remember your u from your earlier statement is that our u is equal to 1 minus x squared. So let's put in our value of u here to conclude. So in that case, we can now say that this is equal to negative x 1 minus x squared to the power of negative half. But remember the question was in radical form. So it's expected that our answer should also be in radical, not in exponent. So we're going to return this to radical, and let's do it together. So to do that, we are going to have, because of this negative sign, you are going to bring down this value here. So this will give us negative x is multiplying. Let's use dots. In your indices, if you have x raised to power m, it simply means the negative sign becomes 1 over. Then you have x to the power of m. Okay? Now, for this, what do you have? This will give us 1 over. This negative will turn to 1 over. Then we return the whole of this, which is 1 minus x squared. And remember, it is raised to the power of half. Okay? It's raised to the power of half. And you know that for it to be raised to the power of half, as we have said it earlier, is the same thing as what? Root of what? This. So this is what we're having now. 1 over square root of 1 minus x squared. So if you simplify further, you are going to now have dy dx will give us negative x multiplies this is negative x all over. Multiply 1 and this we have square root of 1 minus x squared, and this becomes our solution. I hope you learned a lot in this class. Please, if you did, don't forget to give us a thumbs up, share this video with your friends, and remember to follow us for more. And also leave your thoughts with us. It helps us to serve you best. I will see you next. Remember to give this channel a subscription for more are coming. Till we meet next. Bye-bye.